Resting potential is when the sodium-potassium pump works constantly to make sure that more positive ions remain outside the cell than inside the cell. Sodium ions are concentrated outside and potassium ions are concentrated inside. The pump sends 3 sodium ions out of the cell and brings 2 potassium ions in with each cycle and is driven with ATP. Now, depolarization is taking place. Depolarization is when the sodium channel opens so that sodium ions can rush in and cause the cell interior to become more positive. Repolarization is when the sodium channel closes and the potassium channel opens, and potassium flows out of the cell and restores positive charge outside the cell. Now, hyperpolarization is taking place. Hyperpolarization is when the inside of the cell becomes more negative than the outside. The sodium-potassium pump sends all of the sodium ions back to the outside of the cell and all the potassium ions back inside the cell, returning back to resting potential. Now you can see that the inside of the cell is more negative than the outside. In the next diagram, the yellow pieces represent calcium, the orange represent sodium ions, and the blue represent the neurotransmitters. The arrival of an action potential at the presynaptic axon terminal results in calcium ions rushing into the terminal, causing the synaptic vesicles containing neurotransmitters to fuse with the presynaptic membrane. The neurotransmitter molecules are released into the synaptic cleft and attached to neurotransmitter receptors, which then open ligand-gated channels along the postsynaptic membrane that now allow the sodium ions to flow through.